Okay, so we're going to start off here and do a little bit of review for the Chapter 3 test. This is a practice test, and I'm just going to work through some of these problems with you guys. If we can get this to focus for us. Okay, so we're going to graph using the x and the x and the y intercepts. And so we're going to start with this equation right here, y equals 3x plus 6. And 3x plus 6, y equals 3x plus 6 is in slope-intercept form. It's in the y equals mx plus b form. So if we want to graph it using those x and y intercepts, then we have to do what we talked about, where we zero out in order to find the x-intercept and then zero out to find the y-intercept. So if you want to find the x-intercept, we know that anytime you land on the x-axis, the x value is always going to be some number and the y value is always going to be a 0 regardless. Okay, and so this would be the steps that you would take to find the x and the y-intercepts. You would write down the slope-intercept equation, and if you're looking for the x-intercept, you're going to put a 0 in place of the y to be sure that you land on the x-axis. So I'm going to solve this by putting a 0 in place of the y, and just cover this one up over here for a minute, and then I'm going to subtract 6 from both sides, which is going to give me negative 6 equals 3x, and then I'm going to divide by 3 on both sides, and x equals negative 2. Okay, so what that tells you is that your x-intercept is the point negative 2, 0, and then you can come over here and plot that on your graph. Now you can go through the same process to find your y-intercept, because you know when you land on the y-axis that every point on the y-axis always has a 0 in place of the x value. So we're going to solve this equation with a 0 in place of the x value. And when you solve that, you get 0 plus 6, which is 6. So we put in a 0 for the x and we got out a 6 for the y. So that's the ordered pair 0, 6. And we come over here and we graph on the y-axis, we graph the point 0, 6. And then we just connect those together. So that's how you graph using the x and y intercepts. We can go through this process of putting a 0 in place of the y to find the x-intercept and a 0 in place of the x to find the y-intercept. Okay, and then we have this next one right here, and number 2 says we're going to find the slope of a line. So in order to do that, we have to isolate the variable that will be the y here. We're going to isolate the y because we can get this into slope-intercept form, and once we get it into slope-intercept form, whatever's in place of the m, which is the coefficient of the x, that's going to be the slope. And so to begin that process, I've got my work right here. You're going to take that equation, you're going to write it down, and you're going to subtract 6x from both sides in order to get the y all alone, okay, because we're trying to get that y by itself. When we do that, we end up with negative 6x plus 9, and the 6 is sitting right there in place of the m in the y equals mx plus b equation. So we know that our slope is right there, and it's negative 6. Okay, so let's go to the next one. Okay, you also have a few where you have to determine if an ordered pair is a solution, and so I've got my work here for you showing that I'm just going to try those out. The first number is always the x value, the second one is the y, so I'm trying out the ordered pair 3, 9 to see if it's actually a solution to 3x plus y equals 18. So here's where I plugged in a 3 for the x and a 9 for the y, because of the ordered pair we were given, and then you solve the left side, and 18 does equal 18. So we'd say yes, this is a solution, because when you substitute in the 3 and the 9, the left side results in 18. And 18 is equal to 18, so this equation is true, and that means it is a solution. Then we're going to try out the point 60 and do the same process, and right over here I have that, where you're plugging in a 6 and a 0 in place of the x and the y. When you solve this, you get 18 on the left side, and 18 is equal to 18, which is the value on the right side, so again, this is a solution. And then I'm going to try out the point 0, 3. When you plug in a 0 for the x and a 3 for the y, and you solve the left side, you get 3, and 3 does not equal to 18. This is a false statement. So if it's not equal, if the left does not equal the right, then the point 0, 3, or the ordered pair 0, 3 is not a solution of this equation. So we'd say no, because 0 is substituted for x and 3 is substituted for y. Simplifying the left side does not equal the right side. Okay, the next one, this one's a little bit trickier. This one's about parallel, perpendicular, or neither one. So one thing you have to remember here is that if lines are parallel, they have the same slope. If they're perpendicular, they have negative reciprocal slopes. So I'm going to take this first equation and I'm going to rearrange it using what we've learned about solving equations to get the y alone. And whenever I do that, I move actually the first thing I did was I switched these sides. I put the 2y on the left and the 1 plus 6x on the right, so it's a little easier to see when you divide by 2 all the way across that you get y equals 1/2 plus 3x, and that 3 is sitting right here in the position of the slope. It's the coefficient of the x. So our m value here is 3. Our slope is 3 in this first equation. So we have m equals 3 there. Alright, then we do the same thing with the second equation. We just move the 2x over and divide by 6 all the way across. You end up with y equals negative 2/6x plus 7/6. And if you look at this coefficient right here in front of the x, negative 2 over 6 simplifies, you can barely see I've written it right here, to negative 1/3. Okay, so the slope in this equation is negative 1/3. So I have m equals negative 1/3. And if you compare these two slopes, they are negative reciprocal slopes, so that means these lines are perpendicular to each other. Now if you can't remember what negative reciprocals are, this little example right here may help you out. 3/4 is a negative reciprocal to negative 4/3. So you take the fraction, you flip it over, and you give it an opposite sign. So a second example would be if you begin with negative 5, you can think of that as negative 5 over 1. If you flip that fraction over, it becomes 1/5. If it was negative here, the reciprocal of it needs to be positive, so it'll have an opposite sign. And sometimes we also call those opposite reciprocals, or opposite reciprocal slopes. So these lines are perpendicular because if you look at their slopes, they are negative reciprocals, so we would choose C there, that they are perpendicular. Alright, on number 5, we have to find the slope of this line. And it says find the slope of the line if it exists. Now in this graph, you were actually just given this point and this point. And so you would move from left to right and you would drop 3 and run 2. So that means your slope is negative 3/2. Now this other choice said the slope is undefined. Now the only time a slope is undefined is when you have a vertical line, because if you remember, the rise is a number that's not equal to 0. And the denominator here, which is the run, is 0. So if you ever end up with a 0 on the bottom in the denominator of your slope, then it's going to be undefined. But that only happens when you have a vertical line. Okay, let's move on to number 6. If you're asked to graph the line x equals negative 1, okay, so we have x equals negative 1. Now x equals negative 1 means that every x value that you're looking at has a negative 1 in place of that x value. So when you look at your ordered pairs, you can pick any point. Like you can do negative 1, 0, negative 1, 5, negative 1, 2. As long as your x value, this one's sitting right here at the beginning, the first one must be a negative 1, because it says x is always negative 1. And so if you take a look at these points, when I graphed them over here, this is the point negative 1, 0. This is negative 1, negative, whoop, didn't plot that one right. This is negative 1, 0. This is negative 1, negative 2. Here's negative 1, 5. Then I've just added another one in here. This is the point negative 1, 2. Okay, and so if you look at any of those points and you try to find the slope between them, you see that you can only rise from point to point. There is no run. So it might look something like this. If you were to go maybe from this point to this one up here, you would rise up 1, 2, 3, 4, 5, and there is no run. So the rise is 5, the run is 0. This is what we talked about in the previous problem. This is an undefined slope, or sometimes we call this no slope. So again, that only happens though, you only have undefined for your slope whenever it's a vertical line. Okay, taking a look at number 7, it says find the slope of the line. This equation is already in slope-intercept form, so it's in the y equals mx plus b form. There's your y equals, here's your mx plus b. So in place of your m is a negative 5. So the slope here is negative 5. And we would go ahead and type that in here as negative 5. But remember, if you were trying to graph it, it really means negative 5 over 1. So your rise is 5, and, excuse me, your rise is -5, which actually means you're going to drop 5, and your run is 1. So on this little graph that I've shown you, so actually graphing this full equation, we could start at 6 because of that y-intercept, that b value right there. And using our slope, we would drop 5 and run 1, and then drop 5 and run 1, and it could create that line right there. Okay, looking at number 8. Number 8 says write an equation for a line with this given slope, m, and the y-intercept 0, b. So you're given your m, you're given your b, and the y-intercept is the b, the slope is the m. This is slope-intercept form that you're being asked to give an equation for this line. So you can plug in your m, you can plug in your b, and you can get -1x equals -1x minus 1/4 for your equation. Sometimes we drop that -1 off, we just call it -x minus 1/4. But when you're typing that in, you're probably feeling a little more comfortable with having a number there, so you might just want to go ahead and put in -1x minus 1/4 in. That's totally fine. Okay, number 9 says find the slope of a line that passes through some given points. So you have these points, and remember we label this as the first x and y and the second x and y. So that's why we have x1, y1, x2, y2. And then we use this slope formula right here. y2 minus y1 over x2 minus x1. So we're going to do y2 minus y1, which is 4 minus 5, then x2 minus x1. So that's -2 minus -6. And we have a double sign that occurs there because the opposite of a negative is a positive. So let's go ahead and simplify. 4 minus 5 is -1. -2 plus 6 is 4. So our slope is right here. It's -1/4. And we can just fill that in the blank. And again, remember, undefined slopes are only with vertical lines. And the way that occurs is like what happened up here. It's when the x values are the same. So you would only have an undefined slope if you had 2 points where the x values were the same. Okay, let's try another one. Let's look over here at number 10. It says to plot the intercepts and graph the equation. Okay, so cover this up just to get them one at a time here. So we're taking this original equation, and this equation is in what we call standard form. If you remember, this is ax plus by equals c. Okay, that's standard form of an equation. So it's a little bit different than slope-intercept. But one thing that's nice about the standard form is that to find the intercepts, it's very simple. You just put a 0 in place of your y to find your x-intercept, and then a 0 in place of your x to find your y-intercept, like we did on the first problem. So we're going to plug a 0 in place of the y. We begin to solve this. We have 8x minus 0 equals 24, which means 8x equals 24, and we divide by 8. X is 3, so our x-intercept is 3, 0. And you can see here we put in a 0 for the y value, and we get out a 3 for the x. And we have this ordered pair, 3, 0, x, comma, y. So that tells us how we can put that point on our graph. And then we're going to do the same thing, same process, but we're going to zero out the x to find the y-intercept. What's important here is just be careful as you're working this out. When you zero out that x term, don't forget that if there's a sign that's a negative in front of the y term, it drags down with it. So bring that negative down with the 6y and divide by -6 on both sides. You get -4. So when we put in a 0 for the x, we got out a -4 for the y. So we have the point 0, -4. And this is our y-intercept. So we have our x-intercept and we have our y-intercept. So we can come over here to our graph and we can plot the x-intercept at 3, 0 and the y-intercept at 0, -4, and then just connect those together in a line. Okay, I'm going to stop this video and make a second video with the next half of the review, so be looking out for that one.